So this is incomplete. This is what I'm starting with. So I have taught this course before, but I want this time to, this version to be better. And so the books and references, and this is an incomplete list, okay? Because I'm always looking at new books. So there'll be stuff added. A very nice introduction to group theory, which is very easy, but at the same time quite rigorous, is the book by Jones. I like this book very much, Jones, and this book is called Groups Representations and Physics. I know what the mathematicians here are thinking, but it's a good book, even from a mathematical point of view. Number 2, Anthony Z's book. It's called Group Theory in a Nutshell for physics, for physicists. Okay. And number 3 is lecture notes by Hugh Osborne, who is a faculty, he's a professor at Cambridge. So they're also available on the net. Group theory lecture notes, and they're based on a course that he gave in part 3. Part 3 math. Since it's Cambridge, they call it part 3 maths. There's an S there. In North America, mathematics gets shortened to math. In England, it gets shortened to maths. Okay, that's the main difference between North America and the UK. Okay, number 4 is to be added. So I'm sure there's an obvious question in the minds of the mathematicians here. Is this a mathematics course or a physics course? Okay. The answer is it's a math physics course. It's a mathematical physics course where no background in physics is assumed. Okay, so I will motivate all the physics. You know, a lot of the questions we are going to be asking and the problems we will be, addressing do come from physics. And, this is something that happens in the real world. If you're a mathematician and you say, oh, I have no interest in physics, that's fine. That is not a problem. But you have to realize that many of the important branches of mathematics were born and are still being born because physics needs it, or because of its cross-pollination with physics. Okay.